All right, so here's a new strategy that we have not seen before. And again, just to emphasize, one of the more difficult parts of these problems, just figuring out which way should we approach it. It's just like you're going on a journey. You know, the most important part of the journey is make sure that you have the map to get where you're going. Because if you start off in the wrong direction, you're not going to get there. So there's no half angle, there's no double angle, there's no trinomial, there's no greatest common factor. There's not a Pythagorean identity, at least not yet, because there is an identity involving secant and tangent, and it looks like this. It's the one that we used in that other problem. Okay, the problem is that in this identity, secant and tangent are being squared, but in our equation right here, it's just tangent and it's just negative secant. There's no squared. So that brings us to this right here. Okay, the strategy that we're going to use is to square both sides. Why are we doing this? So that we can create one of these identities. So basically, if you're not using strategy 3 and there's an opportunity to make a Pythagorean identity appear, then that's what we're going to do. We're going to make it appear by squaring. Now there's only one other thing to mention when we square both sides, and that's this. At the end of our equation, or at the end of our solution, we will have to check for what are called extraneous solutions. And you might recall this from solving radical equations in algebra, like if you had to solve this right here. If you square both sides of this, you would get x equals 25. But if you plug 25 back in here, square root of 25 is equal to 5. It doesn't equal negative 5. So this is actually an extraneous solution. So whatever our answer is at the end of this, we only have to check when we're squaring both sides, which we do for this strategy and then one of these other ones. I think it's the half angle strategy as well. We're going to have to check our final answer at the end. So let's square this. Remember that when we're squaring something, that's not going to be tan squared plus 1. We have to FOIL this out. It's pretty easy to square this side though. Negative secs, when you square it, is just positive secant squared. When you FOIL this, tan times tan is tan squared. Okay, then we have tan times 1, that's 1 tan. And then this is going to be plus another tan. So tan plus tan will end up equaling 2 tangent. And then finally we have 1 times 1, and that's going to equal 1. Okay, so now we have tan squared plus 2 tan plus 1, but I have a secant squared on the other side. And like we said in other problems, we only want to be dealing with a single trig function. So now we can use strategy 3. Strategy 3 is use a Pythagorean identity. Why are we doing that? So that we can have only tangents in this equation. So let's use this identity. Sec squared, I'm just going to replace that with tan squared plus 1. Okay, so now it might look like a trinomial, but notice what happens if we put this in standard form, which means we make it equal 0. We'll subtract 1 from both sides, and we will subtract tan squared from both sides also. Okay, so that goes away. So now we are simply left with 2 times the tangent of theta, and that's equal to 0. Okay, that's equal to 0. So now all we have to do is we have to solve that for tangent. Okay, and then once we have our solution, we will have to check. So let's divide by 2 on both sides. So we get tan theta is going to be equal to 0. Now remember, tangent is sine over cosine. So sine over cosine in that case is equal to 0. So let's draw our unit circle. Where does this equal 0? Well, we're only concerned with sine equaling 0, because if cosine equals 0, we'd be dividing by 0, and you can't do that. That's undefined. So we only want to know where sine is 0. Sine is the y-coordinate, and the y-coordinate is 0 right here at 0 degrees, and it's also 0 right here at 180 degrees. So our solutions appear to be 0, and they appear to be 180, but remember, we put a question mark there because we have to check. Okay, so let's take this original equation at the top, which is tan theta plus 1. I'll just move it down here so we can see it. So tan theta plus 1 equals negative secant. That's our equation. And all we have to do is just plug each of these things in and check. So let's start by checking 0 degrees. Okay, tan of 0 is 0. 0 plus 1 equals negative sec of 0. Well, secant is the opposite of cosine. So if we go, let's just draw a quick unit circle. Cosine of 0 degrees, that's the x-coordinate right there. X right there equals 1. So this would become negative. Okay, this thing is equal to 1, so we have this. We have 0 plus 1, and that does not equal negative 1. So this is an extraneous solution. That doesn't work. Let's see if the other one works. So let's check 180 degrees. So we'll have tan of 180 plus 1. Does that equal negative secant of 180. Let's check it. So tan of 180, that's the sine over cosine at 180. So that's 180 right there. Sine right there is 0. And well, we already know it was 0 from up here. So this whole thing equals 0. So we get 0 plus 1 equals negative. Okay, remember secant is the opposite of cosine. So what's the cosine right here? Cosine is negative 1. The reciprocal of negative 1, which is secant, that's also negative 1. So we have negative times negative 1, that equals positive 1, and that does equal 0 plus 1. So this 180 degrees is a valid solution, whereas 0 is extraneous. So we don't include that in our final answer.